In this module, we're going to be learning about azimuth. So what is the azimuth? The azimuth is the direction of the solar panels from the observer. It's expressed as an angular distance from north or south point of the horizon to the point at which a vertical line passing through the object intersects the horizon, just like this. Let's simplify this a little bit more so it's easier for you to understand and give the information to your customer. Now, we're going to have points on these rated from 0 to 360 or 0, just like a circle. But it's got to go one step further than that because there's points in between, right? How do we gauge this when it comes to solar? Well, with a compass. When you take a look at the top view of a house from a satellite image, you're viewing it from north, east, south, and west. The top of the image is the north and the bottom is the south. The right is the east and the left is the west. These points for each one are going to be 0 for north, 90 for east, 180 for south, 270 for west, and all the points in between those numbers. So how does this relate to solar and what does it mean for solar? It means the direction of the panels will directly impact the production of the panels. This is crucial to know and to portray to your customers and make sure they understand that. Because if the panel's production is affected by where it's facing, that means that some systems may need more panels to produce the same amount of power as others. Let's take a look at an example. So here's one where we have a due north, south, east, and west. First, if we pull out our compass, we can see that. And every point is going to be determined which way the panels are going to be facing. Now, the slope of the roof actually determines that. And they're going to be put on each one. So 180 is the south roof, east is going to be the 90 degrees, 270 is the west, and 0 is the north. The ideal solar azimuth for peak production is 180 degrees or due south. From sunrise to sunset, the solar panels will receive the optimal amount of sunlight to produce the required kilowatt hours. This may vary depending on the consumer's needs. So what happens when we mix multiple azimuths? Well, the overall factor is going to change. It means that if we have a system that's due south, that system is going to produce more power than a system that has panels all over the roof in different directions. Just like in this example here. So this is going to be an example of a mixed azimuth. We're going to have some panels to the east, to the south, and to the west. Well, this big blank space down here is actually a flat roof. We'll learn more about flat roofs in the next module, but just to give you an idea, we love these things because it's so easy to decide where we need the panels to go and where we need them to face. Let's look at some live examples together. So this is a true satellite image from southern Arizona, and it's determined a couple of these azimuths. So we have 3 different azimuths that we're going to be looking at. So we pull up our compass. We know our north, east, south, and west. And let's take a look at this one here in the center. It's slightly northwest and slightly southeast. So it's not exactly 270, not exactly 90. So it's about 275 and 95. Well, down to the left of that one, we have one that's slightly southwest. And up on the very top of the screen, we have one that's southeast. But it's not directly southeast. It's more south than it is southeast. So it's about 170 degrees. Why is this important to know? Well, if you're working in this neighborhood, there's a good chance that you're going to be selling multiple people in this neighborhood and they know each other. So let's take a look at instances that happen because you're going to come across referrals or neighbors who think they use the same amount of power as their neighbor does or their family member, when in all reality they don't. But let's say, just for argument's sake, that they do. So this is Mary, and this is Bob. So Mary needs 14,500 kilowatt hours a year. So we need to build a system to produce 14,500 kilowatt hours a year. Well, let's say Bob needs exactly 14,500 kilowatt hours a year as well. Well, Mary needs an 8.7 kilowatt system to have 100% offset. But Bob needs a 9.3 kilowatt system. Bob's angry because he thinks you're trying to rip him off. So it's up to us to educate him on what happened for him to require a larger system than Mary. Well, Mary's house is almost completely due south, which means from sunup to sundown, she's going to receive more direct sunlight on her panels all day long, which will ultimately produce more power. Bob's house is east to west facing, which means the morning hours, his east facing panels are going to be producing more power than his west facing panels because his east facing panels get direct sunlight and his west facing panels get indirect sunlight. And then afternoon, it changes. His west facing panels will get direct sunlight and his east facing panels will get indirect sunlight. Now that Bob's educated on the subject, he's no longer upset. He understands that you did what's right for him in his family and his home.